Welcome to a video on factoring worksheet number 1 that discusses how to factor out GCF, or the greatest common factor, from multiple terms in a polynomial expression. So there are 20 questions, and they're all on the first sheet, and the second sheet is just the answers. And it does say that if you can't factor something, write prime. I'll tell you right now, all these are factorable. So prime won't be an option. All are factorable here. But it is always good to keep in mind that, things are not factorable. We do write prime, but don't worry about that because all these are factorable. So all you're doing is you're trying to see what each of these have in common, each of these terms, and you pull them out. For example, 16p4, I know it's the same thing as saying 4 times 4 times p 4 times, right? 4p cubed is 4 times p 3 times. So we see that, okay, the first term has a 4 occurring twice and the p occurring 4 times. The second term has a 4 occurring once and a p occurring 3 times. So what we do is we actually will pull out a 4 and 3 of these p's. By doing so, we have 4 on the outside and the 3 p's. And what's left behind? This single p here and single 4 becomes 4p. And nothing's left behind here, but you do assume there's a 1 being multiplied all of it. So we have plus 1. So it becomes 4p cubed times 4p plus 1. And there we go. Let's take a look at number 2. Now, number 2 can be written as, just 9 times x, or you could break it down as 3 times x, I suppose. But the reason why I didn't break down to 9 is that 36 has 9 as a factor, which is 9 times 4. Going back to number 1 again, 16, I could have broken it down even more. I could have said 2 times 2 times 2 times 2. But I noticed that 4 is already a factor of 16. That's why I wrote 4 times 4 for that one. Let me erase this so it's not distracting. There we go. So anyway, when I look at number 2, I do see that 9 is a factor of 36. So I can break down 36 as 9 times 4. So I could pull out a 9 from each of these. And what's left behind? X and a 4. And there you go. I pulled out the greatest common factor for number 2. Okay, let's jump to a couple of more advanced problems. You can see we got numbers 1 and 2 correct, so that's awesome. All right, so for number 19, we have 3 terms. Now, I noticed that one has an x squared, one has an x. So not all of them have x's. But I do notice that 64, 40, and 72, I suspect that 4 is a factor of each of those 3 terms. And feel free to use a calculator if you need to. Like if you can't do 72 divided by 4 in your head, feel free to use a calculator. Your cell phone could work, or a normal graphic calculator, or on a computer, or Desmos, anything like that. 4 times 18 times x. So they all have 4s in common. But I could probably break this down even more. But let me just pull the 4 out, just get that out of the way. So 16 plus 10x squared plus 18x. I also notice that all these are divisible by 2 still. So I can pull out a 2, so it becomes 8 plus 5x squared plus 9x. And it looks like that's as far as I can go. So it's 8 on the outside. And usually I'll try to write these in descending order of powers, 5x squared plus 9x plus 8. So I pulled 8 out. If you could have seen that there's an 8 as a common factor among 64, 40, and 72, more power to you. But if you can't, that's okay, because whatever's left behind, you still want to examine it further and see if there's still more stuff you can pull out. Now, fortunately for number 20, I do see that 3 is a factor. So that's -3 times 6n squared plus 3 times 5n minus 3 times 5. So I'll just pull a 3 out. But then the negative still gets attached to the 6n squared plus 5n. And I pulled 3 out from -3 times 5, but I'll leave the negative next to the 5 because I just pulled out 3, not -3. And there you go. The 3's been pulled out. We go down below, and looks like we got it. And remember, when you're factoring stuff out, you also want to guarantee that if you were to put the 3 back in or the 8 back in for number 19, that you want to get back to the original expression. If you distribute the 3 back into that group with the parentheses, you should get back to the original expression. Likewise, if I put the 8 back in, you should get back to the what we had originally. So that concludes this video.